Alright, so here's the second part of that homework we got, 7.8 here. So the first one's kind of review, talking about volume and surface area. Okay, now, notice we have the same length for the base, length and width, but not the height. So volume is simply length times width times height. So 3 times 3 times 2, so we'd get 9 times 2, which is 18. So 18 feet cubed. Now, surface area is essentially finding the area of all of these sides. So the right and left side, the top and the bottom side, and then the back side, as well as the front side. Okay? So we essentially have all these areas of all these pieces. Okay? So the top and the bottom are going to have the same area, 3 by 3. Okay? So I'd go 3 times 3, but then we double that. So that would be 18 feet squared for the top and the bottom. Okay? Now we're going to worry about the right and the left. So that would be 2 times 3 and 2 times 3. So 2 times 3, and once again there's 2 of them, so I'm going to double it. So it'd be 6 times 2 would give us 12 feet squared. Okay, so we got the top and the bottom, the right and the left, now the front and the back. The front here as well as the back. That once again is 3 by 2, so that would be 12 again. So we'd have, add on all these together, would be 12, we'd have 42. So our surface area would be 42 feet squared, because it's area, not volume, it's squared. Okay, the way to think about it is volume is how much it takes to fill up this box with stuff inside. Surface area is how much wrapping paper would it take to wrap around. Okay, that's surface area. That's the difference there. Okay. Now, for number 3, we'll jump back to number 2 in a second, but number 3 is very similar. Okay, volume, base, times width, times height. So we'd go 20 times 12 times 8. And we get 1,920 inches cubed. Now for surface area, first we do the top and the bottom. Okay, because they're going to have the same dimensions. So it'd just be 20 times 12, which is 240. And then because there's 2 of them, we do it twice, so I double that. So we get 480. Okay, then I would do the left and the right. So that would be 12 by 8, so 12 times 8, which is 96. We double that because there's 2 of them, so that would be 192. And then the last, the front and the back, which would be 20 times 8. So 20 times 8, and then which is 160. We double that because there's 2 of them, and we get 320. So we add those all together. 17, 19, 5, 8, 9. And we'd have a surface area of 992 inches squared. Alright. Now for our cylinder, the way we get volume is we get the area of the circle and we times it by the height. So the volume is pi r squared times h. Okay, so my radius is 2. So I go 2 squared, which is 4. Right, so it would be pi times 2 squared, and the height is 6. So 2 squared is 4. 4 times 6 is 24. So it's 24 pi, so I'd go 24 times pi. Which gives us a volume of about 75.40. 75.4 inches cubed, because it's volume. Now for the surface area, okay, we've got 2 circles. So I find just the area of the circle, which is pi r squared, and double it. So pi is, the radius is 2. So 2 squared, which is 4. Then times that by pi. We get about 12.57. Then we're going to double that because we have the top and the bottom, or the front and the back. So we end up with these two circles being 25.13 inches squared. Okay, now if we were to cut this open, what would be that shape of the inside piece? If we rolled it out, it actually ends up being a rectangle. Okay, now the distance of the long side is 6. The distance of this side, well, that is the circumference. So it'll be 2 times pi times the radius of 2. Okay, or in other words, 4 pi. Okay, so 4 times pi. Okay, then we're going to times up. That's this length right here, so that length right there is about 12.56. Times that by 6, and we get 75.4. So our surface area ends up being about 100.53 inches squared. All right. Oh, wait. I thought through this wrong. This would actually be on this part. The 6 would actually be the side. That's right. Same concept, though. Same answer. Just visualization different. All right. So let's take a look now. So we started talking about radians in class. And remember, we came to the conclusion that a radian is that length of that radius wrapped around the circle. Okay? So it's using that radius to measure the distance around, another way to measure the angles, the arc length of the circle. Okay? So let's look at what this wants us to do. So it says below are circles of radius 1, 2, 3, and 4 units. Okay? So each of them has a diameter drawn that cuts them into 2 equal sectors. Find the arc length of 1/2 of each of those circles. Then find the radian measure of the arc length for each one. Okay? So, first off, we want that arc. So remember, the formula for arc length is the measure. So it would be 180. Each of these cases, all these measures are 180. Divided by 360 times 2 times pi times the radius. Okay? So we're going to do this and change that radius each time. Now, if I go 180 divided by 360, that gives me 0.5. 0.5 times 2 is going to give me 1. So I can actually simplify this part because I know all of these angle measures are the same. So that becomes 1/2 times 2 times pi times the radius. That just becomes 1. So it's really pi times r here. Okay? So if I go 1 times pi, we get pi, or 3.14. Okay, if I go 2 times pi, we get 6.28. If I go 3 times pi, I would make this next radius here 9.42. And then for number 4, if I go 4 times pi, we get 12.57. Okay, now it wants the radian measure of half the circle. Okay, so if you remember, what we then did to figure out that radian measure was we divided by r again. Okay, which if we divide by r here, we're just going to end up with pi. So the radian measure of half of each of these circles is 3.14, or in other words, they're all pi. So that radian measure of half a circle is always going to be pi, no matter what length the circle is. That's kind of the result we want to get out of that. Okay, let's move on. Number 5, there are 3 circles below, each with a different radius. The same size angle, 45 degrees, has been used to create a sector in each circle. Fill in a table with the length of the arc measure for the sector, the radian measure, and the area of the sector. Okay? So, length of the arc, we do that again, right? So radius of 10, so we'd go 45 degrees over 360 times 2 times pi times our radius. Now, we could try to simplify this one again. If we go 45 divided by 360, we'd get 1.25. Oh, 0.125. If we times that by 2, we actually get 0.25. So that would become 0.25 times pi times the radius. Okay? So the radius of 10, we go 0.25 times 10 is 2.5 times pi, and we get about 7.85. Now if we do the same thing with 20, we get 15.71. And we do the same thing for 30. We end up with 23.56. Okay, now if we're doing the area of the circle, remember area of a circle is be 45, because they're all 45 degrees, over 360, times pi times the radius squared. Okay, so I go 45 divided by 360, which is 0.125. So if I just wanted to do this, we could do that as well. Now this is the area, so I'd go 0.125 times pi times the radius 10 squared, so if that were 10 squared, that would be 100. And we get 39.27. Okay, and that would be units squared. If we did it for the radius of 20, we go 20 squared, then times that by 0.125, and times that by pi, and we get 157.08. Then we do it for 30 squared, times pi times 1.25. So 30 squared times 0.125 times pi. And that gives us about 353.43. Okay. Now for the radians, okay, what we need to do is take that number and divide it by the radius, right? So 7.85 divided by 10 give us 0.785. And then if we did 15.71 divided by the radius, we get 0.785, possibly 786 if we round. And then 23.56 divided by 30 give us 7.85, 0.785 I should say. So in radians, that would be 0.785. Now here's the interesting thing, okay, because these radians would all be the same because their radii are bigger or smaller. That 45 divided by 360 over times 2 was 0.25. We write that as a fraction as 1 over 4 times pi times the radius. Now, no matter what the radius was, we ended up with the same thing. So if we erase that, and then we join that up there, we end up with that radian measure of 45 degrees being pi divided by 4. Okay? Another thing, if you're ever given not the radius, the angle measure, and you want to find out its radians, okay, well, if we look at that formula, okay, we went the angle measure over 360 times 2 times pi times the radius. But to find the radian, we divided by the radius, so that eliminated our radius. Okay. Then, if we simplify this, 2 divided by 360 would actually be 1 over 180. Okay, so we can simplify that by getting rid of that and make that 180. Then, because it's the angle measure that changes, we could swap those out, and it's actually pi over 180 times whatever the angle measure is going to give you the radians. Okay, and that's another formula that you can end up using. Okay, so now it says, use the 3 circles in problem 5 to find the following ratios. So the ratios, so arc length here, because we're doing arcs, so EF would be the smaller one, so EF to BC, so 7.85 to BC, which would be 15.71. Okay, we also want to do BC, 15.71 to JK, which is the bigger one, which is 23.56. And then EF to JK would be 7.85 to 23.56. So let's find out what we get when we do all of these ones. Okay, so 7.85 divided by 15.71. That gives us 0.4996, so basically 0.5. We could round that up to. Okay, what about this one? So 15.71 divided by 23.56 gives us 0.666, so basically 0.7. It was 0.6668. Okay, so we could round up to 0.7. And then this last one, 7.85 divided by 23.56 gives us 0.333, which essentially would be 0.3. Okay. So, do we notice anything about the ratios? Well, they all seem, they're less than 1. There kind of seemed to be a pattern. I'd wonder if we did this one to circle with a radius of 40, what we'd get. That would be 0.9. Okay, and that one became 0.3. So, looks like there is some sort of pattern there. Okay. Alright, 7 says, considering EF above in problem 5, how many copies of this arc would be needed to equal the length of the entire circumference of circle D? Okay, so in other words, how many of these arcs would it take to get the entire circumference? Well, let's find the circumference. 2 times pi times the radius. So 2 times 10 is 20, so 20 times pi would be 62.831853. It keeps going, so I'll leave that in the calculator. And let's see how many. Let's divide by 7.8. 5. Oops, dang it. We get about 8.004. So it would take about 8 of them. Okay. Now it says, what would this be true for the other arcs and circles in the problem above? Why? Okay. So we could take this one, find its complete circumference, so that would be 20 times 2 would be 40, so 40 times pi. So that's 125 and some decimalage. We divide that by 15.71. We end up with 7.99, so basically, yes, 8. Okay, if we did it with the other one, 30 times 2 would be 60. 60 times pi is 188.49 stuff. Divide that by 23.56, and we get about 8. Almost exactly 8. So yes, it's true for all the other arcs, and why would that be? Well, let's think of it this way. How many 45-degree angles can we make in a circle? Well, what's 360 divided by 45? You should already know the answer to that one. It's going to be 8. So because that represents that 45-degree angle, it would take 8 of those lengths to get us a full circle, because it takes 8 45s to get us our angle. And that's pretty much the answer to those ones. Alright, so let's jump and look at these last problems. So we've got two circles, same central angle. So it says find the arc length of GH. So we go 135 over 360 times 2 times pi times the radius of 2. So 135 times 2 times the radius of 2 divided by 360 times pi. We get about, hold on, and we get 4.71 centimeters. Now it wants us to find the length of our x. So 135 divided by 360 times 2 times pi times the radius of 6. So 2 times pi times 1, or 2 times 6 times 135 divided by 360 times that by pi, and we get about 14.14 centimeters. Okay, then it says find the area of the small sector, so now we're finding the area of these. So we go 135 over 360 times pi times the radius 2 squared. Okay, and when we type that in, 2 squared is 4 times 135 divided by 360 times pi, we end up with 4.71 centimeters squared. Okay, for the bigger one, circle T, 135 times 360 times pi times 6 squared. So 6 squared is 36 times that by 135 divide by 360 times by pi, and we'd end up with 424.12 centimeters squared. And I think I might have written this wrong. Put the decimal in the wrong place. 42.41 centimeters squared. There we go. That's a little better. It says now find the radian measure of 135 degrees sector in each circle. So remember, we take this number right here and divide it by its radius. So we go 4.71 divided by its radius, which was 2. So for the smaller circle, we get the radian measure of 2.355. Okay, if we do it for the bigger one, 14.14 divided by 6, and we get 2.356 repeated. Now they're slightly off because we rounded our decimals. Now remember, back here we talked about being able to use this. So according to this formula, I should just go 135 degrees times pi divided by 180. So if I do that, 135 times pi divided by 180, I end up with 2.356. Okay, so it works. Okay, now what is the ratio of arc GH to arc RX? So that'd be 4.71 over 14.14, which 4.71 divided by 14.14 gets us about 0.3331. Okay, what about the ratio between the two sectors? So that'd be 4.71 divided by 42.41. And that would be about 0.111. Alright, so there we go, guys. That's the second video for this homework. So some interesting things there. Hopefully you got to practice some of that, and there we go.